Hello children. Hopefully you all are enjoying your this COVID-19 period, staying at home with your family and giving more time to your studies. So children, we are discussing about the substances which are in our surrounding, whether it is pure or not pure. Generally we prefer the pure things, but is it actually a pure? That science says all the substance which are made up of only one kind of particle are pure, but rest all are not pure because they are made up of more than one kind of particles in various ratios and can be separated by various physical means. So the things, most of the things which are in our surrounding are not pure. We call them as mixture, like the sea water, air, soil. These are mixture because they are a mixing of different particles and without any proportion. There is no fixed proportion. Like in compound you have studied, which is a type of pure substance, there the atoms of different elements or of same element, they combine in a fixed proportion and the combination is chemically. They combine chemically and you cannot separate them with any physical means. But here we are talking about the mixture. Mixture are those substances which are made up of different kind of components in various composition. Now when we are talking about the mixture, mixture is divided into two types depending on the components of the mixture, and they are homogeneous and heterogeneous mixture. In homogeneous mixture, the components are evenly spread throughout the mixture and you cannot distinguish their boundaries from each other. Like if you take salt in water, if you dissolve it, you cannot differentiate the particle of salt and the particle of water. So these are called as homogeneous mixture. Homogeneous mixtures are also known as, generally we call it as solution. But when we say solution, it comes in our mind something which is liquid. But actually it can be in the form of solid also, liquid as well as gas. But we have given names to them. Like if the solution is solid, then we call them as alloy. Like the brass. Brass is an alloy where there is a mixture of copper with zinc. Copper and zinc, they are mixed together but the ratio is 70:30. Copper is near about 70% and zinc is of about 30%. In this way they are combined. Same way bronze is also their alloy. Bronze, and then steel. Steel is also an alloy. So these are the examples of solid solution. Like liquid solution, if we say, if you dissolve sugar in water, it is liquid. Salt in water, copper sulfate in water. These are the solutions in liquid. Even there is gas solution also. Like the air. Air is a mixture of different gases. And these different components of the gas, that is the nitrogen, oxygen, carbon dioxide, inert gases, water vapor, these are present. They are not in a fixed ratio. Although we studied in the composition of air that nitrogen is 78%, oxygen is 21%, your carbon dioxide is 0.03%. So in this way you have studied. But in some places, like if you come to a crowded area in your any city, crowded place where there is lot of vehicles moving, the pollutant is more. Maybe the carbon dioxide level is more there. If you go to forest area, there the carbon dioxide level may be less. So the composition can vary. It is not a fixed composition. So these are the different type of solutions we have said. Now other examples are tincture of iodine. Tincture of iodine in which the iodine is added to alcohol. So iodine is the solute and alcohol is the solvent. You have studied about solvent and solute. When the substance in which we are adding, that is called the solvent. And the substance which we are adding to make solution is solute. Solute plus solvent is solution. So in tincture of iodine, iodine is solute and alcohol is solvent. So here you can see the solid is dissolved in liquid. Another example, aerated drinks, cold drinks which you take. In that the carbon dioxide gas is filled in the syrup, which is called as aerated drink. When you open the mouth of the bottle, the fizz sound which comes out, that is nothing but the escaping of the carbon dioxide gas. So here in liquid, gas is mixed. So that is also a solution. Now coming to, when we say solution, depending on the amount of solute, we call the solution as dilute and concentrated. If less amount of solute you dissolve in solvent, it is called a dilute solution. But if we add more amount of solute in comparatively less solvent, then we call it as concentrated. So solution can be said as dilute or concentrated depending upon the proportion of solute in the solvent. If the solute is less, then we call it as dilute, and if the solute proportion is more in the solvent, then we call it as concentrated solution. Now there is a limit. At a particular temperature, you can dissolve the solute, and to some extent you can keep on dissolving. After that, at that particular temperature, you cannot dissolve it. You cannot further dissolve the solute. So that solution where you cannot further dissolve the solute is called as saturated solution. Such solution where the solute cannot be further added in the solvent at that particular temperature is called as saturated solution. But if the temperature increases, if you increase the temperature of that solution, it again becomes unsaturated, because when you heat, what happens? The particles move away from each other. You have studied in first chapter the kinetic energy. So they gain the kinetic energy, and now the particles are moving away from each other, and that time they have a space. So further you can add the solute and make it, you can further add and you can make it as supersaturated solution. Because after supersaturated solution, if you cool it, what happens? If you remember, you have studied crystallization. So crystals are formed. So that is supersaturated solution. Now the amount of solute dissolved in solvent at a temperature is called its solubility. How much amount of solute is added in the solvent? So that is called as solubility, and find out how much solute is present in the given solvent or in the solution, we have the concentration of solution is equal to amount of solute divided by amount of solvent or the amount of solution. And if you want to find out its concentration, then you have to multiply by 100. Percentage. If you want to find out the concentration of the solution in percentage, then you know when you have to calculate the percentage, you multiply by 100. It is multiplied by 100. So you can find out the concentration of solution by dividing the amount of solute given upon the amount of solvent or amount of solution. If they ask you what is the concentration of the solute in a given solution, so you can write that solution. Suppose I have given you 4 gram of sodium chloride is dissolved in 100 ml of water. So if I ask you what is the concentration of solute in the given solvent, then you have to simply divide 4 upon 100, and if I ask you about the percentage, then you have to write into 100. Now if I ask you what is the concentration of solution if the amount of solute added is 4 grams in 100 ml of water. Now it is being asked what is the concentration of solution. Now here you have to add solute plus, you have to add the solute plus solvent. Now it becomes solution. So 4 divided by 104. That is the concentration of solute in the given solution. And if it is asked the percentage, then you have to multiply with 100. So this is the formula, and sometimes they give you that find out the mass by mass. Mass by mass percentage means the solute is also given in mass, gram, and like the solvent is also given in grams. Then we write it as mass by mass percentage. If it is given mass by volume means the solute will be in grams and the solvent will be in liters. Okay. Next is volume by volume. If both are liquid, so how much space it is occupying? It may be in the, they can give you in cc or they can give you in ml. Whatever they give, so that you are finding out the volume by volume percentage. So these are the different methods to find out the concentration of solution. So in concentration of solution, you are finding out that how much amount of solute is present in the solvent or in the solution. So this is about the homogeneous mixture, which we call it as solution. Okay. Now coming to the other type of mixture, which are called as heterogeneous mixtures. They are called heterogeneous because the components in this type of mixture, their boundaries are visible. They are not uniformly spread. You can see their boundaries. That is why they are called as heterogeneous mixture. One thing, in solution, there are some properties, children. Like the solution, in the solution, the components are evenly spread. Their boundaries are not distinguishable. Second thing, the component or the particles which are present in the solution, they are very small. Very small means less than 1 micromillimeter. That is 10 to the power minus 9 meter in diameter. It is less than that. That much small it is. And because of the small size, they are unable to scatter the path of light. you know when does the light path visible? When the light gets reflected. But as the particles of the solution are so small that the light are not able to fall on its surface. Particles are so small. That is why the light passes through. It is not reflected because of the very small size of the particles. And this is the reason why you cannot see the path of the light through these solutions. Because of the small size, it cannot be separated through filtration, because through filter also it passes down. It cannot be separated. The components cannot be separated by filtration, sedimentation, decantation, because the particles are very small. And because these particles are uniformly scattered and they do not settle down. If you don't disturb it, it will never settle down. It cannot separate its boundary. So we call them as stable. They are stable in nature. So these were the properties of solution. Let us come to now heterogeneous. Heterogeneous are further divided into suspension and colloid. In case of suspension, the components are quite big. It can be seen with your naked eye. And as it can be seen with your naked eye, like the example is mud, muddy water. In the water, if you put some soil, if you stir it, you can see the particles. And if you leave it undisturbed, you will find that the particles, they all settle down. So when you stir it and the particles are for the time being scattered in the solvent, that is in the liquid medium, if you pass the light through it, the light will show the path. The path will be visible, which is called as Tyndall effect. Because the particle size is big and it is able to scatter the light, because of which the path of the light is visible. And as these particles are quite big, they settle down when they are undisturbed. So they are unstable. Example is mud water. Chalk powder, if you put it in water, that also it is an example of suspension. Next is colloid. Colloid is a mixture which lies in between solution and suspension. They are although bigger than the size of the solution component, but not as big as suspension. Okay. So the size is intermediate. Not as small as the solution particles and not as big as suspension. But they are stable. They don't settle down. If you leave it, it will not settle down. But the particles are a bit bigger, so they can show Tyndall effect. That is, it can scatter the path of light. And to separate the components of colloid, there is a special technique called centrifugation. Centrifugation, that is a method of rotating the mixture in a high speed. Very rapidly it will move. Then what will happen? The denser one will go on the bottom. It will be forced to go on the bottom, and the lighter one will come on the top. So in this way you can separate the component, like the milk. Milk is a colloid. And when you churn it, at home also, you must have seen your mother, she is churning the milk. Or even nowadays we are using the mixie. In mixie we are rotating the milk and the cream comes on the top. Okay, so that is the method of separating the colloidal mixture. Okay. Now, in colloidal mixture, there are two parts. Like in solution, we have said the substance which is in larger quantity in which it is dissolved, that is called solvent, and which is in lesser quantity which is dissolved, that is solute. Same way in colloid also, there are two parts. One is the dispersed phase, another is the dispersed medium. You can just compare dispersed medium with solvent. Dispersed medium means in which the components are present. Dispersed medium means the component which is larger in number. That is called dispersed medium. You can understand it in the form of solvent. You can make it dispersed medium means solvent and dispersed phase means solute. So the dispersed medium can be gas, liquid or solid. When in the gas, that is the dispersed media is gas, and in that if liquid is dissolved, liquid is the dispersed phase, it is called as aerosol. And the example is fog, cloud. They are the examples of dispersed medium gas and dispersed phase liquid. If the dispersed media is gas and the dispersed phase is solid, so solid is in gas, then also it is called aerosol. Okay, like the smoke, then the vehicle exhaust, the black color substance which comes out. That is the solid which is mixed with gas. That is aerosol. These are called as aerosols. Next, when the dispersed medium is liquid, and in liquid, if the dispersed phase is gas, it is called as foam. If the dispersed medium is liquid and dispersed phase is also liquid, then we call it as emulsion. And if the dispersed medium liquid and dispersed phase is solid, then we call it as sol. Example of foam, it is shaving cream. Shaving cream is an example of foam. Emulsion is milk, face cream, they are the emulsion. And sol is milk of magnesia. Okay, that is an example of liquid and solid is the dispersed phase. Same way now, if the dispersed medium is solid, and in that if the phase is gas, we call it as foam. If it is phase is liquid, we call it as gel, and if the phase is solid, then we call it as solid sol. Okay. If in solid gas is mixed, when we call it as foam, the example is foam. Rubber. These are examples of solid medium and phase is gas. If the medium is solid and phase is liquid, we call it as gel, like jelly, cheese, butter. They are the examples of gel. Same way, in solid medium, solid phase is there, then it is called solid sol, like colored gemstones, milky glass. They are the examples of solid sols. So this is the way we can say that colloid, like the very good example of colloid is the forest canopy. In the forest canopy, you can see the sunlight passing through. And in that light path, you can see the dust particles moving. So that is the colloid, example of colloid. So I hope you have understood this. So thank you children. Goodbye.